Alright, how are you doing, guys? Hope you're doing great. Today we're going to talk about functional groups, the main players. If you want to learn organic chemistry, you should start from functional groups because they are the key for organic chemistry. So if you don't know the functional groups, you should not move further in organic chemistry. As easy as that. What are the functional groups? These are the groups which can perform their own functions. They carry their own functions. They have their own properties, own characteristics. Each and every functional group is different and distinct from all other groups. So there are so many functional groups in organic chemistry. I will try to divide and classify them. First class of functional groups is based on hydrocarbons. That means those functional groups which contain carbon and hydrogen atoms only. Basically, if you want to know the definition of organic chemistry, in simple words you can say it's a chemistry of carbons. Yeah, if you are really beginner in organic chemistry, this video is for you guys. So this is alkane. These are the carbons: CH3, CH2, CH2, CH3. Another functional group is alkenes. So anything which contains double bond is called alkene, and there are two types of alkene. So one is internal alkene and other is terminal alkene. So internal alkene and terminal alkene, and alkenes also can be cis and trans or E and Z. This is the stereochemistry of alkenes. We will discuss in another video. I hope so. So this is the terminal alkene, and if we have a double bond in between, this is called internal alkene. Okay, because it contains double bond in the middle of the chain, and it can be cyclic as well. I mean, this is called cyclic alkene, and alkanes can also be cyclic, like this is cyclic alkane, yeah, if you want to know. Yeah, and alkenes can also be EZ, cis trans, but as I said, we will discuss E and Z, cis and trans, in another video where I will describe the stereochemistry of alkenes. Okay, next functional group in organic chemistry is alkynes, which contains triple bond. So you can select this triple bond from here. This is triple bond and has long chain. Okay, so this is alkyne because it contains triple bond. And like alkenes, alkynes can also be of two types: internal alkynes and terminal alkynes. Terminal alkynes, and you can also prepare alkenes from alkynes. This is another video I will make where you can interconvert functional groups. Internal alkynes. So definition of internal and terminal is same. So if you have a triple bond in the middle of the section, like in this example, it's called internal alkyne. But if you have a triple bond at the end of the chain, then that's called so this is a carbon chain. Try to, okay, so if we have a triple bond at end of this is called terminal alkynes. Okay, alkynes hard to be in cyclic form, you know. Yeah, but I don't know they can be cyclic or not, I'm not sure. But anyways, so 3 functional groups we have discussed so far. I will delete these ones and we will discuss further on. By the way, these were the hydrocarbon based functional groups. Another is benzene. It's also in a hydrocarbon. If it's substituted benzene, like substituted means it's contained with 1 R, then it's phenyl. We call this as phenyl, and we call this as benzene, 6-member ring. This is for school or college chemistry, guys, this video especially, because this is really simple organic chemistry. It's a starting point for organic chemistry. By the way, if you haven't subscribed my channel, please subscribe this channel and like, share and comment, please. Thank you. Okay, this is benzyl. Also, if you have a CH2 unit between benzene and some R group, we call this benzene. Okay, these were the hydrocarbon based functional groups. What were they? Alkane, alkene and alkyne, plus benzene, phenyl and benzyl. These were the hydrocarbon based functional groups. Next type of functional group which I'm going to classify, that is without carbonyl group functional groups. So one is alkyl halide. X is a halide. X. So X is equals to chlorine, chlorine, bromine, iodine, and the name of functional group is alkyl halide. If the R is alkyl, then we call them alkyl halide. If R is aromatic like benzene, we call them aryl halides. By the way, I'll make another video in which I will explain which compounds we call aromatic and how to determine whether or not this compound is aromatic or not. And also, okay, let me maybe do here. Yeah, okay, let's do it here. There are 3 types of alkyl halides. There are 3 types of alkyl halide: primary, secondary and tertiary. So primary alkyl halides, we call them Rx 1 degree. Beg your pardon, 1 degree. Okay, let me try to put degree right. 1 degree. Secondary alkyl halides, we write them as 2 degree. And tertiary alkyl halides, and that is 3 degree. So how to identify whether or not this is primary or not? If your halogen group is connected with, like this is bromine, this is connected with a carbon, and that carbon should be connected further with 1 carbon, or it should contain 2 hydrogens. That is called 1 degree or primary alkyl halide. It's not necessary that it should always contain 2 hydrogen, but this is a simple technique. So this is a bromine connected with this carbon, so this carbon should be connected further with only 2 with only 1 hydrogen, or with only 1 carbon and 2 hydrogens. That's primary. So this is secondary alkyl halide. If you have, let's make it bigger. 1 2 3 4. Okay, then this is this, and secondary carbon, if I put 1 carbon more here, so Now this carbon, which contains bromine, is connected with this carbon, and it itself contains only one hydrogen. Let me point out the hydrogen so you can see what I'm talking about. So this is primary because this carbon contains two hydrogens and a halogen, that's why we call it primary hydrogen. But if you look at this carbon, this contains only one hydrogen, so that's why we call it secondary alkyl halide. And another one is tertiary alkyl halide. So when we replace last hydrogen with methyl group, that's when we say this is tertiary. Now if you see, this carbon does not contain any hydrogen. So primary, two hydrogens; secondary, one hydrogen; tertiary, no hydrogens. These are the three types of alkyl halides, and let's remove them. Okie dokie. Done this, we are done with alkyl halides. Next functional group which does not contain any carbonyl group or does not belong to hydrocarbons is amines, or some people say amines, NH2. So amines is another functional group of organic chemistry which contains no carbonyl group, only NH2. So if R is alkyl, we will say alkyl amines. If R is aromatic, we will say aryl amines. What I mean by aryl amines is this: we call this aromatic if we attach NH2 on benzene ring, so this becomes aryl amine. If we do not attach anything and we make a long chain out of it, so now this is alkyl amine because it contains alkyl chain, alkyl amine. By the way, there are three types of amines as well, similar to alkyl halides, and they can be classified in the same way: primary, secondary, and tertiary. So primary, secondary, and tertiary. So primary amines, now you have to look for nitrogen rather than carbon. Okay, so in alkyl halides we were looking for carbon containing hydrogens, but here we will see amines. If amine has two NH2 groups, that is called primary amine. It does not matter how many is there. If there is two carbons here, three carbons there, it doesn't make it tertiary. This is not tertiary amine, even though it's tertiary carbon, but it's a primary amine. Okay, so you don't look for carbon in amines classification, you look for nitrogen. Nitrogen contains two hydrogens. Whoa, that is primary then. Okay, how about secondary? If nitrogen contains one hydrogen, that is secondary amines. By the way, these primary, secondary amines, you need to know these, because then I will make another video about acidity and basicity of organic compounds, where you have to determine which is more basic, primary amines, secondary amines, or tertiary amines. If you don't know what is primary amine, what is secondary amine, what is tertiary amine, then you will not be able to predict which is more acidic, primary, secondary, or tertiary. You need to understand the difference between these different functional groups, different classification, and different types. Okay, further, the last type of amines is tertiary amines. If the nitrogen does not contain any hydrogen, so that is easy. So you look for the tertiary amine, you look for the hydrogens attached on the nitrogen atom. That's it. So this is tertiary amine. Again, this is a functional group which does not contain any carbonyl group. Similar to amines is another functional group, that is amides. The difference between amines and amides is amides contain additional carbonyl group, both have NH2. Amines and amides have NH2, or NH are just N, but amides also contain. We will discuss in a few moments later. Okay, next functional group which does not contain carbonyl group is alcohols. OH, ROH. So OH, if you see, is the alcohol. By the way, if you see OH on the benzene ring, that is not alcohol. So that will be phenol. It's kind of a different functional group. It's a different properties. Does not resemble to alcohols in the acidity character or other properties of solubility, melting point, whatever. Okay, so primary alcohols, and there are three types of alcohols: primary, secondary, and tertiary. So we can classify alcohols into three categories: primary, secondary, and tertiary. Now you have to look for the carbon. Primary alcohols, and by the way, primary alcohols are indicated by 1 degree, same as primary amines. So if I write 1 degree like this, you should be able to understand that this is primary alcohol, right? So primary alcohols are those functional groups which contain carbon which is further attached to only one substituent or contains two hydrogens. See this, where my blue color dot is, this carbon contains two hydrogens, and that's why we call this as a primary alcohol. So let me put that to hydrogens, 1, 2. This is primary alcohol. How about secondary? Is similar to alkyl halides, we did it. So if there is one hydrogen on this carbon, if I remove this one hydrogen, now this becomes CH3 unit. I don't need to write it, you assume it, there is CH3. So this is secondary alcohol, because it contains one hydrogen and the last one. Okay, and secondary alcohols are denoted as 2 degree. Okay, and the last one is tertiary alcohol. Okay, and this is tertiary alcohol, and then this one, oh sorry, come here back. Okay, if I remove this last hydrogen, this also becomes CH3. So this is, I don't need to write it, you understand this area where blue color is CH3 unit, but anyways, okay, I need to replace CH3. So this is tertiary, and tertiary is indicated by 3 and degrees. Okay, so these were the three types of alcohols, and we will understand which type of alcohol is more acidic. By the way, there are simple analytical techniques where we can determine and test how to identify certain functional groups, like Lucas test is used for alcohols, tolerance reagent is used for aldehyde and ketone. I will make videos for those as well, don't worry. Okay, now next functional group is ether, that is ethers. Ethers are functional group which do not contain carbonyl group, and they contain 2 R groups and 1 oxygen. Okay, so simple ether is dimethyl ether, which contains 2 methyl groups on both the sides, and the common ether which is used in the lab is diethyl ether. So ethyl groups on 2 sides. So this is a commonly used solvent in organic synthesis reactions. It has own its properties, boiling point, and everything different from all functional groups. There are 2 types of ethers, not primary, secondary, or tertiary, but symmetrical ethers and unsymmetrical ethers. Symmetrical ethers and unsymmetrical ethers. Unsymmetrical ethers. So if your ether is contains same groups on both sides of oxygen, that's called symmetrical ether. But if your ether is different, like for example here, it's okay, this is ether now unsymmetrical because one side is different from the other side. The central point is oxygen, so you stop at oxygen and look on the both sides. This is symmetrical ethers. Okay, there are no primary, secondary, tertiary ethers, thank God. Okay, next to ethers is thiols. Next functional group is thiols. They are very similarly, super similarly compounds. If you are doing the experimental work, let me remind you, I have done a lot of sulfur based synthesis in my research works. So these are thiols. These are similar to alkylides. Instead of X there is SH, and I don't know, these are not common in organic chemistry, but I think we can classify them as primary, secondary and tertiary as well. But okay, sorry, okay, so I will write 1 and a degree for primary, 2 degree for secondary and 3 degree for tertiary. And so this is our thiol primary, which is connected to CH2, 2 hydrogens next to it. This is primary thiols, like similar to alcohol as well, you know, just instead of oxygen we are putting sulfur here. And the functional group also ols, like thio is for sulfur, ols like alcoholic properties. Okay, anyways, this is secondary because it contains 1 hydrogen. Yay. Okay, then the third one is which does not contain any hydrogen, that is tertiary thiols. Okay, let's move further to next functional group. We are done with this. Next is nitriles. They contain cyano group or cyanide group, so they are called masked carboxylic acid group, because if you do hydrolysis of cyanides you will get carboxylic acids. That's it, we are done with nitriles, and we are almost done with the functional group which do not contain carboxylic carbonyl compound, carbonyl functional group. So what they were alkyl halides, just a recap. They were amines, they were alcohols, there were ethers, there were thiols, there were nitriles. Done. Now the third and most important type of functional groups is with those functional groups which contain carbonyl group. Okay, so first, by the way, as I mentioned earlier, this video is for school students or college students who wants to learn. It's a very basic video. Or if you want to start to learn organic chemistry, you must start by learning functional groups. So this is the beast which we call the carbonyl group, carbon double bond oxygen, that's it. So now all the functional group which we are going to describe here will revolve around this unit. So this is the first member. Let's see how carbon groups. This is aldehyde. Okay, and here we don't say primary aldehyde or secondary aldehyde or tertiary aldehyde, but instead of that we define alpha, beta and gamma. So this is the carbon next to carbonyl group is called alpha carbon. This is really important when you will do the reactivity or reactions of carbonyl groups. You will find this helpful. So this is beta carbon, and the last carbon is tertiary, and if you go further, quaternary and tertiary, whatever. And this carbon, which is called alpha carbon, if this contains any hydrogens, then we will call them as alpha hydrogens. Don't forget that. And this concept is applied to all carbonyl groups. So like next is ketone, acid chloride, amides, carboxylic acid, esters. So we will call them, if the carbon present next to carbonyl group, we will call that alpha, beta, and tertiary, or gamma. Gamma is a better, sorry, so gamma, not tertiary, gamma. Okay, next functional group is ketone, which is very similar to aldehyde, but instead of one hydrogen on the one side of carbon, there is R group. That is ketone. Similar to aldehyde, if there's one carbon, we call it alpha, second carbon beta, third carbon gamma. Hydrogens attached on alpha carbon, we call them alpha hydrogens. Hydrogens attached on beta carbon, we call them beta hydrogens. Hydrogens attached on gamma carbon, we call them gamma hydrogens. Next is acid halide. So acid halide is the derivative of carboxylic acid. Or let's do one thing. So number 4 is derivatives of carboxylic acid. Okay, these contain carbonyl group, but they come mainly under this family. Okay, let's divide into a fourth category. By the way, you can classify them according to your own choice. This is not the final thing. You can, whatever works for you or easy to identify them. So this is carboxylic acid. It contains carbonyl group and OH. So this is the important carboxylic acid. Okay, next from the carboxylic acid we will move towards the next functional group, which is derivative of carboxylic, because it's derived from this, that is acid chloride. And next to acid chloride is amide. So this functional group is called amide. If we replace NH2, and same amides could be primary, secondary, and tertiary depending on number of hydrogens attached to this nitrogen. The next functional group is esters. So if we replace this NH2 with O and R, this becomes ester. And next is, oh, I'm running out of space. Okay, so if we acid anhydride, I hope I can write it here. So this is acid anhydride, this is ester. So this is acid, again this is derivative of carboxylic acid. Okay, so acid anhydride, this was acid anhydride functional group. I think that's it. And yeah, couple of more functional groups which do not fall into this category which I missed. I think one is epoxides. These are the epoxides. If there is oxygen, these are called cyclic ethers as well, or cyclic ethers, or epoxides. And other ones are disulfides, means they contain 2 sulfur atoms. They are also without carbonyl group. Sulfur, these are called disulfides. And if they contain, this is very sheet based functional group, it's quite common in organic synthesis chemistry and readily synthesized functional groups. Sheet based chemistry is quite well known, last aldehyde or ketone. We call them imines or Schiff bases because they are named after Schiff. Schiff was a person who first identified them. Then there is nitro compounds. They contain nitro groups, not the next ones. And there are nitro-alkyl nitro compounds. So these are also functional groups which do not contain carbon group, nitro compounds, nitro group. And there are several others maybe, but they are not as common in organic chemistry. If you stick with these functional groups, these are enough for you guys if you are beginner. But as I said, there can be so many other groups, as for example thioethers. Thioethers is easy, like if we replace this oxygen with sulfur, this becomes thioketone, and there are also azides. Okay, let's remove this clear space. You can pause the video and note down these functions. Okay, let's remove. Now there are more functions. I can remember from my memory is azides and N3. So azides. These are minor functions, not major. And then there are also nitrous compounds like this one are carbocation chain, but instead of two. So these are called nitrous compounds. And then there are thiols as well, if like aldehyde, if you remove one oxygen of aldehyde, so this is aldehyde, if you remove this oxygen with sulfur, they become thiols, aldehyde thing. And sulfides, they combine sulfur instead of sulfur is discussed earlier. So one sulfur sulfide, and azo compounds. So these are compounds which contain nitrogen. These are photosynthesis, which is from light. These are azo compounds. The benzene is azo-benzene. Azo compounds. Azo functions. The end of azo function. There's also sulfuric acid when you want to go deeper for chemistry, like you need to replace the carbon of acid with sulfur. That will come on the sulfuric acid. So if I this is carboxylic acid, remember, and if I replace carbon with sulfur, that becomes sulfuric acid. I'm doing very detailed stuff. You can pause the video, download the groups. We want to remove these because I was happy with this. Then sulfuric acid function groups which contains sulfuric acid group. So this is sulfur. Anything that starts with sulfurs contains sulfur. So sulfur groups. subscribe in order to learn organic chemistry or more interesting videos about chemistry. I'll keep posting those videos in next few days. This is sulfonic acid, and if you want to know ester of this, like in the carboxylic acid, that becomes sulfonic ester. You can act as a protecting group chemistry. I will run temperature and everything. So sulfonic acid, this becomes sulfonic ester, ester, and there are also sulfoxides because they contain sulfur double bonded with oxygen. This is oxygen, so these are called sulfoxides. There is also thiourea. If I can pull out that structure. Yep, this is thiourea and urea as well. This is urea and this is thiourea. Very common functional groups, Then there is imide as well. Imide functional groups instead of amide means where I can write. Okay, I need to again erase this. You can pause the video to note down these functional groups. There is imides, not amines, but amides, not amides. Okay, and this carbon group there, this there, this, oh sorry, this, oh god, come on. Okay, then this is carbonyl, and this is nitrogen. This is R1 or 2 or 3, whatever. So these are called imides. Lectons if you are talking about cyclic esters. This is the lecton ring. If you have a nitrogen there, that becomes lecton. NH. This is lecton. Beta lectons, if you have heard of them. Lectons. And if you talk about the cyclic functional groups, then you might have heard of these cyclic compounds. Okay, let's try this. I'll remove this. These are cyclic ethers, but we call them acetals. So they are protecting groups for aldehyde or ketone carbon groups. Acetals and isocyanate groups. Isocyanate functional group, that is N double bond C. I'll use type it R N C. Okay, and then okay, how should I do it, man? So RC RNC. Okay, RNCO. So one oxygen there. Okay, so these are called isocyanates. Isocyanates. Isocyanate, if there is sulfur and a triple bond there, then they become thiocyanate. If I remove this oxygen with nitrogen and then put sulfur there and remove this double bond from here. Now they sorry, there should be a triple bond. Now they become thiocyanates. Instead of isocyanate, they become thiocyanates. Phosphines, if they contain phosphorus, they are important for Wittig reagents, phosphorus containing. Anyway, this was very long tedious list of functional groups. I tried to cover every single organic functional group in this video lecture. I'm sorry it's long, but if you watch it till the end, you will find all the functional groups, all the major functional groups most commonly used in organic chemistry. If you really want to develop and learn organic chemistry, you need to start from functional groups. This is the basic point. This is the first point you should start learning, and everything will go from there, like nomenclature, reactivity, synthesis, spectroscopy, retrosynthesis, characterization, you name it. You go everywhere from this direction, from this starting point. I hope you like this video, and please subscribe, like and share this channel, and see you guys with the next video lecture. Thank you, bye, take care.